Hey everyone, and welcome. We are getting ourselves more into probability. So I just decided to, you know what, let me just come on here. Let me get myself together. So, you know what, I can get a nice night. So when we're dealing with probability of simple events, we're looking at part over the whole. That's what it just kind of reminds me. What you're looking for. So we got our part over the whole thing. When I mean the whole, I mean the total. Okay, so we're kind of looking at just simple fractions, and we're looking at what we're looking for over the total amount. Okay, so we have a container that contains 2 blue, 1 green, 4 yellow, 4 orange, and 5 yellow marbles. So we want to find the probability of each of these events, write it in the fraction in the simplest form. So we have 2, okay? We have 1, so that's a 3, and 4, that's 7, and 5, that will give me 12. So I know that we have a total of 12 marbles. Okay, so we're basically looking at the situations. So the P means probability. We're looking at the different situations in which it's going to be out of the 12. So if we take a look here, we got our blue. I'm going to kind of zoom in so you can see. So the probability of getting a blue. So we have 2 out of the total. So if we're looking at 2 blues and the total amount is 12, we got 2 out of 12. But this can be simplified to 1/6. So the probability of getting a blue out of all these marbles is 1 out of 6. Now, looking at the green. So there is 1 green marble. So we got 1 out of 12. Okay? So you can write your proportions like this is a fraction. I know some people generally write their proportions with the colon, meaning 1 out of 12. That's also acceptable as well. All right? Well, thanks for coming in and thanks for the love, everyone. So now we want to get the probability of getting an orange. So you have 4 oranges that's in there. So we have 4 out of the 12. So if we're looking at 4 out of the 12, reducing that, knowing 4 is my most common, that's going to give me 1/3. So the probability of getting an orange is going to be 1 out of 3. All right, you see how it's really not that super technical? Okay, so now we're looking at getting a step up here. So the probability of getting a green or a blue, right? So we want to know how many total blue and green marbles there are. So if we take a look here, we have 2 blue and we have 1 green. So there's a total of 3 of those marbles because those are the marbles that we're looking for over the total number of marbles that's in, let's say, the container. So your probability is going to be 3 out of 12, which that can be reduced to 1/4. Okay, so 1/4 of the marbles that's in that container, you got a chance of getting a green or a blue marble. All right, so now for number 5, we're looking at blue or yellow. So we want to know how many blues, again, we have 2 of them, and then how many yellows, which we have 5, which gives me a total of 7. So 7 out of the total number of marbles, which is 12, 7/12 can't be reduced. Okay, so it's just going to stay 7/12. Now, then we got the probability of getting a yellow or a green. So remember, there was 5 yellow marbles and there is 1 green marble. So if there is a total of 12 marbles in this container, and the possibility of us getting a yellow or a green is like 6 of those marbles, 6/12 can be reduced to 1/2. So you have a half chance of picking either a yellow or a green marble. All right? Hey, thanks, Lynette. Then, sometimes in the test, they'll ask you these questions. The not, so the negations, right? So we know that there's 2 blues, there's 1 green, there's 4 orange, and there's 5 yellow marbles. But they want the probability of it not being an orange. So let's think about it. If we know we got a total of 12 marbles, and we know ahead of time that 4 of them are orange, so how many of them are not orange? Okay? It'll be 8. Right? So 12 minus 4 will give us our 8. So the probability of you picking a marble that's not orange is going to be 8 out of 12. But 8/12, they're both even. That means it can be simplified. And yes, a lot of people want to do it by 2, but I'm going to do it by 4. So 8 divided by 4, that will give me my 2. 12 divided by 4 will give me my 3. All right. Hey, Pog. Good. All right. So the probability of you getting a marble that's not orange is 2 to 3. Now, how about not yellow? So if we recall, there was 5 yellow marbles. So what do you think my probability will be if we have 5 yellow marbles? But what would be the probability of not getting a yellow marble? Go ahead, put that into the chat. So if we have 5 yellow marbles, there's a total of 12. What's the probability of not getting a yellow? Okay, so Pog is saying 7. Awesome. Yep. Because all you have to do, good, is Craig or Reed. Hi, hello. All right, so we know we got 12, subtract 5 from them, that will give us our 7. And then 7/12 can't be reduced. So since it can't be reduced, it just stays at 7/12. Now here's another one. Let's see if you can get this one. What's the probability of getting a red marble? Put that into the chat. What's the probability of getting a red marble? Oh, thank you for the rose. I appreciate it. And all the gifts. So fun. Okay, Pog is saying 0 to 12. So for us to get a red, and they're like, wait, can I see the beginning again? Sure. Let me unzoom a little bit and let me show you the problem. So we had 2 blue, 1 green, 4 orange, and 5 yellow. Okay. All right, there we go. Okay, Dolores, take a look. Okay, if you notice, we have blue, we have green, we have orange, we have yellow. Is there any mention of a red? No, there's no mention of a red. So that means the probability of you getting a red is going to be 0 out of 12. Because there are no reds whatsoever in that container. Okay. All right. So this is basically probability of simple events. Okay. So if we were to construct a model, okay, so we're reaching up. If we are trying to construct a model, especially on this spinner. So let me take a zoom in for the spinner for you. So we have certain spots. So we have orange, green, yellow, green, green, orange, blue, green. So if I were to design the outcomes, and sometimes some people have what's called a frequency table. So the outcomes that we can have an orange, we can have yellow, we can have green, and we can also have a blue. Okay, so those are my total outcomes. So when they say frequency, it's almost like how many spaces hold orange, how many spaces hold yellow, hold green, and hold blue. So let me slide over. So for the orange, we have 1, 2 spaces. So I'm going to put in 2 tally marks. For yellow, we have 1. That's it. So that's going to be 1 tally mark. For the green, we have 1, 2, 3, 4. So it's going to be 4 tally marks. And for the blue, just this 1 lonely blue. So altogether, how many spaces? What is my sample space? How many spaces are being represented here in this spinner? Go ahead, put that into the chat. How many spaces? Good, good. Okay, good. There we go. There it is. I don't know what that little caricature is, but whatever you are, 8, okay? So we have a total of 8 sample spaces. So that means my probabilities is going to be out of 8. So all we're doing is putting our frequency as my numerators. So this will be 2 out of 8. This is 1 out of 8. This is 4 eighths. And this is 1 eighth. So now 2 eighths can be reduced to 1/4. 1 eighth and 1 eighth, that are going to stay exactly the same. But 4 eighths, that can be reduced by 4, which gives me a 1/2. So these are the probabilities of the chance that these outcomes will show up randomly if you spin the spinner. All right. All right, cool. So I know this session is going to go by rather quickly. Because it's not super duper technical, but at the same time, it's good and beneficial for you guys to know and to understand where all this stuff is coming from. So if you can, go ahead, follow. If you know of anyone that will benefit from this, please do not hesitate whatsoever, to share the live, tap away. I'm just going to try to do everything. So now for this one, basically everything for 11, 12, 13, and 14 is exactly the same that we just had. So we know we said the orange was 1/4. Okay, for the green, that was 1/2. For the yellow, it's 1/8. And for the blue was also 1/8. So that part we get. But now let's look at the negation. So when we get our orange or green, so we want to take a look. We can use the information that we have or the previous information. But if we want to figure out how many orange or green is possible for it to pop up, what do you guys think? You have a learn test tomorrow? What do you have to learn? Okay. Yes. So all we have to do is add them. So we know for the orange, okay, we had 2 of the orange originally. Oops. Got a little slid over a little too much. Okay, so we have our orange, 2 of the orange. And then we had 1, 2, 3, 4 of the green. So if we take a look, we have our 6 out of 8. But 6/8 can be reduced to what? Yep, still have the same denominator. But 6/8 can be reduced to what? Not 2/4. Yeah, since they're both even, they both can be divisible by 2. So we have 3/4, 4/8, not 4/8, 3/4. Good, Cameron. So for the 6 and the 8, they're both even. If you divide both the numerator and the denominator by 2, 6 divided by 2, that will give me 3. 8 divided by 2, that'll give me 4. So 6/8 is reduced to 3/4. Good. Nice job. So the probability of you getting an orange or a green is going to be 3/4, 3 out of 4. Now, not green. Okay, not green. So if we have 8 slots, what out of 8 is not green? Okay, thank you. So not green. So we're saying like 4 out of 8, which reduced to our 1/2. So good. At 50%. Yep. Okay, now that's 4/8. Yes, and 4/8 can be reduced to 1/2. So if they're both even, but 4 and 8, they both have 4 in common. Okay. The second question. Oh, okay. All right. So now let's take a look. So this time, I'm going to see if I can shrink it some more. Probably not. All right. So we have a set of 12 cards, numbered 1 through 12. Suppose you pick a card at random without looking. Find the probability of each event, write as a fraction in the simplest form. All right. So they told us how many cards we have. We have 12 of them. So everything is going to be out of 12. For you picking a 5, it's going to be 1 out of 12 because there's only 1 5 in that deck of 12 cards. Right? Easy? How about getting a 6 or 8? What would be my probability? Okay, so I got 1/6. Yep, so you got 2 out of 12, which can be reduced by 2 to get my 1/6. Good, there you go. Now, the probability of getting an even number. No problem. The probability of getting an even number. It's all right, you can get this one. Now reduce it. 6/12. What is that reduced? Exactly. Okay. We're dealing with 1 through 12. Not 0 through 12, but 1 through 12. So that means we have 12 numbers. Generally, half of them are going to be even, right? So if you say, okay, I got 6 out of 12, but if I reduce it, it's going to still give me 1/2. Okay, so the probability we got is at 1/2. Now, how about the probability of getting a 1, a 3, or an 11? Okay, the probability of getting a 1, 3, or 11. Okay, 3/12, yes. Could that be reduced? Good, 3/12, good. Can that be reduced? There we go. There we go. Now we're talking. Now we're cooking. So yes, you will have your 3 out of 12. And reduced will give you your 1/4. There you go. Good. All right. Last one for this. Multiples of 5. What would be the probability? Cards, 12 cards, numbers 1 through 12. Multiples of 5. What would that be? Okay, so I'm seeing 1/6. I'm seeing 1/6. 1/6. All right. So the two numbers that we had was 5 and 10. So 2 out of the 12 numbers. Reduce that will be 1/6. There you go. Good. All right. Okay, simple, easy, right to it. Okay, not too crazy, not too technical. So, to keep this party going, we're going to go into what's called the difference between, let's see if I can find it real quick. The difference between the two types of probability. Okay, so we saw the probability of simple events. So now we're going to look at it from the experimental or theoretical. So if you want, and this is going to be our last bits for tonight. Okay, so theoretical, let me zoom in for ya. Okay, so when we got that theoretical probability is basing on knowing and calculating all the equally likely outcomes of the experiment. So basically it's what should happen. All right, just like how we just did the spinner. Did we actually spin the spinner? No. Okay, I know a lot of people hate probability, including myself. But guess what? We can't escape from it. Because if you notice, you can play around, especially when you get down to statistics. You can play around with the numbers as much as you can. You can make something sound so awful or so incredible just based on how you perceive what the numbers are. So I just want to break down these concepts because there's no escape from it, okay? So when you do a theoretical probability, it's just like what we just did. We didn't spin a spinner, okay? We didn't spin a spinner. We didn't have a container of marbles. We just theoretically know what a marble looked like, know what a possible container could look like, and we just got the probability from that. Whereas the experimental probability, that's what you're actually doing. So you're actually spinning the spinners. You're actually picking the cards from the deck. You're actually pulling a marble from a container. All right? Okay. Oh, cool, Ryan. All right. So when you're doing experimental, you're actually doing the experiment, but you're looking at it based at the repeated trials. So here's the thing. In order to get as close as likely for that outcome to likely happen, the more trials that you do. So if you do something, you're like, oh, I just did this. I flipped this coin 20 times. Okay, congratulations. But you're going to need to flip that coin almost 1,000 times in order to get a really good read, a really good, accurate, probability. So it's not just flipping it 20 times that's going to cut it. You're going to need to flip it a heck of a lot more, right? So if you notice, the theoretical was the number of favorable outcomes over the number of possible outcomes. Whereas the experimental is the number of outcomes that occurred because you're actually doing it over the number of trials performed. Okay? How many times did you get tails? I had to censor myself. So how many times did you get tails when you flipped the coin? Okay? And how many times did you flip the coin? Okay? So if we're looking at it, here's a lovely example. If you flip a coin, what is the theoretical probability that you will land on heads? Okay? So if you flip that coin, what is the probability that you're going to land on heads? Okay? Put it in there. So Ryan is saying 1/2. Do we agree or do we disagree? Okay, so Pog said 1/2. Izzy says 1/2. Okay, anyone else? Because I do agree with the 1/2. Because here you go. You got two sides of the coin. One of the sides is going to be tails, right? Now, if I flip that coin 20 times, how often should you land on tails? So if I flip it 20 times, how often should I land on tails? What do you think? Okay. JR is saying 10. Pog is saying 10. Ryan is saying 10. Okay. How are they getting this? Well, if I did it one time, it's going to be 1/2. If I am flipping it 20 times, half of 20, that's going to give me 10. Okay, so this is doing it one time. This is theoretical. Okay, now if I were doing the experiment and literally taking a coin and flipping it 20 times and recording what I get as my result, that would be experimental. Okay, do we see the difference between the two? Because some people are just like, I don't know the difference. And they always have a question. Is this theoretical or is this experimental? Okay, theoretical, it's all based on theory. Do you have a random coin? Do I have a random coin? Oh, I do. Yay. All right. Oh, I got a nickel. I'm rich. All right. So here is my tails. Here is my heads. Okay. So if I were to flip this coin multiple times, okay, 20 times, and I record it, obviously I'm not flipping correctly. You know what I'm saying. But I used to love doing this thing. But anyway, if I flip my coin 20 times and I keep record of how many times I flip it, that is experimental. All right. So now we have one more. Let's see if I can get it all in here. Slide down, slide up. Okay. So example. Okay, below are the results of choosing a card from a deck of cards, recording the suit, and then replacing the card. Okay, pause. Now, this is the one thing about being a teacher. I always ask a lot of my students, have they ever seen a deck of cards? And I'm actually currently tutoring a kid that has never seen a deck of cards before, because of her culture and her religious belief in her family, okay? There are some families that do not believe. I'm not sure if I can even do this. Actually, I can. I'm going to do it like this. There are some families that do not, have never, ever seen a deck of cards. So, deck of cards, you have different suits. And those suits, you have diamonds, you have clubs, you have hearts, you have spades. And as you can see, you have aces, you have twos, threes, fours, fives, six, sevens, eight, nine, tens. Then you have your face cards, which are jacks, queens, and kings. Okay? In a standard deck, there are 52 cards. Okay? If I want to take a look right here, just so people can have it. Because this is the thing that drives me nuts with some standardized tests. They don't take that into consideration. That there are some cultures that don't gamble. So they have no idea what a die look like. They have no idea what playing cards look like. And it's like a lot of people just don't take that into perspective when they're doing these assessments. So you wonder how many people that probably failed the test all because of their belief. Makes you think. All right. So, not to poison your minds. Hopefully I'm not putting you to the edge like, I saw a playing card and I want to play cards. And all of a sudden their whole life goes down the toilet because I did this. Anyway, this is just perspective. All right, so there's 52 cards in the standard deck. There's 4 suits. You got your face cards. Your black cards are your clubs and your spades. Your red cards are your hearts and your diamonds. All right. So I know some people like to have a deck with the jokers in it. We're not talking about the jokers that make you go wild. Okay. So say that we had, let me put this aside. Okay. So say that we drew 6 hearts. Then we drew 10 diamonds. Then we drew 7 clubs and 5 spades. So how many cards did we pull? Okay, put it in the chat. How many cards did we pull? Okay. So Ryan's telling me 28. Do we agree? Okay, got Keeger's telling me 28. All right. Liz is telling me 28. Pog, you still there with me? Or are you working? There's Pog. All right. It's the worst unit AP stats for me. Really? All right. So if we add them all up, that means we're going to have a total of 28 cards. So it asks, what is the probability of choosing a diamond? So we know that there are 10 diamonds. So I'm going to put that over here. So we have 10 diamonds. So 10 out of the 28 were diamonds. But they're both even. So that's telling me that this can be reduced. What's 10 28ths be reduced to? There we go, Ryan. Ryan, you're going to do awesome on your test. Okay. So 5/14, because if I divide the numerator by 2 and I divide the denominator by 2, I'm going to get 5/14. Good. Bald bacon head. Okay. So you reduce it by 2, which will give you your 5/14. Okay. Now, let's switch over to the other side. Okay, so a lot of the stuff that we're going to be doing is going to be theoretical. Because it'll just seem weird for me just over here flipping coins just for its and giggles, right? All right. So now we want to find what's the probability of choosing a jack from a standard deck of cards. All right. So let's take a look. So how many jacks do we have? How many jacks do we have? Jacks in the box. Okay, good. We got 4, we got 4, we got 4. Okay, Pog, don't forget. We got our diamonds, we got our clubs, we got our hearts, and we got our spades. There we go. Good. Okay, so if there is 4 out of the 52 cards, okay, someone wrote it up there. What is that reduced to? I think Thomas and someone else, I think, had it up there. Or maybe it was just Thomas. Hold on. Yep. So far. Oh, no. Jenny. And then we got Ryan. Okay. So they're both even numbers. Okay. So they are definitely divisible by 4. So 4 divided by 4 gives me 1. There you go. Good. And then 52 divided by 4, that'll give me 13. If we think about it, you got your suits. This is just basic that, or are there problems here accounting for multiple? Yeah, we're just doing like with the basic right now because a lot of people are just needing it for their GED, acuplacer, all that stuff. All right. So that was 1/13. So now for the next one, what's the probability of rolling a composite number? Ooh, on a fair number cube. Now, we gotta love our number cubes, aka dice. But I remember, again, there's a lot of societies that are not into the whole die thing, okay? All right, so all I know is there are 6 sides to a cube, and this is for my people that do not gamble. So you have 1, you have 2, 3, 4, 5, and 6. What is a composite number? Like, they're getting really deep. What is a composite number? So are composite number even numbers? Not necessarily. Not necessarily. Okay, one that's not prime. True. So through multiplication, okay, through multiplication, if you can get more factors other than 1, okay? So if I say 4, for instance, if I want to multiply to get 4, I can do 1 times 4 and 2 times 2. So I have more than just 1 in itself, which is a prime number. Now, I always ask this question. The first prime number is 2, not 1. Okay? Please, for the love of sakes. Because if you notice, every time you do some kind of factor of a number, the 1 is being used. 1's being used in the 2's. 1's being used for the 3's, being used for the 4's, the 5's, the 6's. Okay? So 1 is being used constantly. So when it comes down to those composite numbers, we're dealing with, yes, 2 out of 6. Because the 2 composite numbers is 4 and 6. Because we got 1 times 4 and 2 times 2. In order for me to get a 6, that's 1 times 6 and 2 times 3. So I'm looking at 2 out of the 6's, which reduced will give me 1/3. Okay, we're doing good. All right. Yes. Nice. All right. So let me leave you alone with this one. What is the probability of picking a vowel from the word mathematics? Now, it might be tough for those that are doing English as a second language, but I think you might be able to pull it off. Okay. Okay. So I got 4 out of 11, 4 out of 11, 4 out of 12, 4 out of 11. Dark side saying 4 out of 11. Cookie saying 4 out of 11. Izzy 4 out of 11. Pog, good job, 4 out of 11. Okay. So a vowel. Let's go back to it. So we have our A, our E, I, O, and U. Okay? Not doing that Y stuff. Sometimes Y. Sometimes. All right? Not each and every time. So we know we have A, we have an E, we have an A, and an I. So that's 1, 2, 3, 4. So we have 4 vowels. And it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters in mathematics. So since 4 11s cannot be reduced, the only number that 4 and 11 have in common is 1. So we just keep it as 4 11s. All right? So that's going to be your probability. Again, for me, this is type of question that doesn't really take in consideration if English is the second language. Okay? But here we are. All right? So let's... I'm learning English too. Yep. Learning while doing is extremely hard. Is extremely hard. But I appreciate and I love the fact that you are trying. All right, so let's go this bad boy in. So now we have the following question was asked to survey 6th graders at Wake County Middle School. Okay. What college in North Carolina do you want to attend? So that was the question that was asked. Below are the results. So 95 students said NC State. Okay. 60. Did you hear about what's his name? He wants to go to the NBA, but we'll talk about that later. Duke. 60 students said Duke. 45 students says North Carolina, and 50 students says East Carolina. Now, this is going to be an interesting question because if you are not in the know with certain things, this is going to be a tough question for you to answer. But I'm here to kind of break things down. All right. So when it comes down to the first question, it asks, find the probability of a student choosing NC State. So before we can do anything, we need to know how many total students are we talking about? Okay, how many students are we talking about? And my dark side of the moon, how did we get the 50? Because how many total do we have? There we go. All right, so we got our 250s, 95 out of 250. Great. All right, awesome. All right, so we have 250 students, okay, total. So as mentioned, how many wanted to choose NC State? Well, it was 95 out of the 250, which can be reduced, and that's what Dark Side of the Moon put up there, okay? It can be reduced to 1950. So this is the probability of getting NC State. So I should actually write this appropriately. Okay, so the probability of NC State. Okay. Yes, you did. I don't know your name, so I'm just going to call you Dark Side of the Moon because your thing is black. All right. Now, slowly going over to number 2. Find the probability of a student choosing either East Carolina or Duke. So I know it's going to be, so I'm going to say East Carolina or Duke. Okay, I know it's going to be out of 250. But how many students want to go? Okay, I can put it right there. East Carolina or Duke. Okay. Good. Good. Dark side of the moon. Good, Ryan. Ryan, you're going to rock this test, man. Good, Lizzie. All right. This is awesome. So we have a total, because we add up the Duke, which is 60. We add up East Carolina, which is 50. So that gives me 110. And if I reduce it, remember, this is one thing I could do. They both end in 0. If they both end in 0, I can just knock out those zeros to simplify. Okay? So that will give me my 11 out of the 25. Okay? That's one way that you can simplify. So you don't have to put in your calculator, especially if they both end in 0. Just cancel out the zeros and then take what remains. No, don't drop out. Just use me as a resource. Okay? Just use me as a resource. All right? So now, here we are with number 3. So find the probability of a student choosing a college that doesn't have a shade of blue as their school color. Now, that's you getting to know the schools. Okay, so what school or schools doesn't have blue? So let's see if we can help out the ones that may or may not know. Independent and dependent? I wasn't planning on it. Because actually this was going to be like a quick one. Okay. Which school doesn't have blue? I know. Really got to think about it. All right. Is everybody like going online? Let me see. Okay, so we know that Duke is blue. Okay. Everybody knows North Carolina. Well, maybe not everybody knows, but North Carolina is definitely blue. I mean, they have their own blue color. Or is it red? Nope, Duke is blue. You're right. Good job. Oh, wait, international. So Duke is blue. North Carolina is blue. NC State is red-ish, like maroonish. And so is East Carolina. So you see how that question would be, really biased. Because we don't know, right? Unless you're in the know, you won't know. So the ones that are not blue is NC State and East Carolina. So I know it's going to be out of 250. But it's going to be what out of 250? Okay. Stella. Good. Good. Excellent. Good. I love it. So 145. Because all we had to do is add together NC State, which is 95, and East Carolina, which was 50, which gives me 145 out of 250. Since both of them are multiples of 5, because this is ending in 5 and this is ending in 0, so that means I can reduce this. And last time I checked, this can be reduced to, I think Dark Shades of the Moon said 29 out of 50. So that's the probability of a student choosing a college that doesn't have a shade of blue. Good. Good job. That's it. Good. All right. All right. And the last one, it's going to be a doozy. And I definitely am going to help you out with this one. All right. Find the probability of a student choosing a college that is located in the triangle. And you're like, what? What triangle? Where's the triangle? So there is a bunch of schools that is, I think I'm going to do this right. I'm not sure. That is like a fair distance away from each other. And I might screw this up. And if I do, go ahead and correct me. Because I think Duke is here. I think. I'm trying to remember. You have Duke. Nope. Duke is up here. Duke is up here. This is supposed to be North Carolina. And then you have NC State. Something like that. I could be wrong. But they're fairly a distance away from each other. Okay? Yeah, I saw this somewhere. Yes. So they're a fair distance away from each other. The only one that's not in this triangle is East Carolina. Okay? East Carolina is not in the triangle. So let's just think about it. Okay? So I'm doing the probability of triangle colleges. or colleges in the triangle. So if there's a total of 250 students, and we know 50 of them want to go to East Carolina, and East Carolina is not part of this triangle, so it's going to be what out of 250? Remember all this. Practice. Well, here's my thing. I'm constantly doing stuff. Okay, so POG, yes. So we know there's 50. So if we take 50 away from 250, that's going to give me 200. And since both of them end in zeros, I can cancel out the zeros. And it'll give me 20 over 25. But we know that 20 and 25 are multiples of 5. 1 second. Wow. Sorry, I had to unhook to hook in. There we go. All right. Which, since they're both divisible by 5s, will give me 4/5. All right. Yep, so we got our 4/5. Got it right again. Good. All right, so how are you guys feeling with this? Thumbs up, thumbs down. This is mad easy. Or can you make it a little more challenging? Okay. Yes, you got it right again. Hey, King Cash. Nice to see you. Continue to review to make it more challenging, though. Okay. Light work. Okay. Thank you, Pop. He's like, tap it up, guys. Because I know this woman is putting a lot of work into this. Yeah. So that actually puts a close to my notebook. So before I continue on, if you guys can tap, that'll be awesome. I do have a couple more that I want to solidify the experimental and the theoretical probability, and I'm going to stop there. But if you like the design of my notebook, I actually designed this. I just got tired of a lot of my math kids just having notes everywhere, and it was making me crazy. So I tried to have something where you can actually put the formulas down, and you can actually put the steps down, and you can do some of the work on the side to keep track of it. It's great for when you're doing open notes quizzes or just to organize your thoughts. Okay, so it's kind of inspired from a Cornell Notes. So, and if multiplication is not your thing, I also have a factor sheet. So if you need to do any kind of factoring, breaking down radicals, I have numbers from 1 to 200. Then also all the other resources, the basic concepts that a lot of people generally miss, like adding, subtracting integers, multiplying integers, what are the rules, also the order of operations, powers of exponents, linear and quadratics, and just a couple of things for geometry as well as for trigonometry. I'm currently working on my updated version of this. So it's like 100 pages for notes. Both, it's going to be dot form as well as the grid. And then you can use basically both sides of it. I'm making copies of all my notes, and I'm actually going to sell them. Like, you know how you used to have like Cliff Notes? You're going to have like Audrey Notes. So you can have anything that you want. If there's a paper that your teacher definitely wants you to leave in your notebook, you can actually tape it to one side and then do the summarization of what's on that paper on the other side. So this is for 7th through adult learners. And I do have one that is for younger students. And I just kind of make that a little bit. Okay, cool. How can I find this? If you go to my website, if you go to my picture, just click on my profile. And this is for the younger ones, so they can get used to writing their numbers and having everything lined up. They also get the resources as well. So they still get the factoring resources and some factor charts and, you know, changing from percent to fraction, fraction to decimal. Then also they have the fraction operations, long division, decimal operations. So yeah, click the link in my bio, go to my website, look under the Ultimate Math Notebook, and it will take you directly to Amazon. I am currently working on getting myself self-published. I like Amazon, but you know, I would love to get more piece of the pie, if you know what I mean. It's just life, right? So yes, this is from 4th through 6th, whereas I have this cover as well as, this cover for the 7th through adults. So anybody can fill all their information in. They can type bits and pieces of their notebooks in there. So everything will be under one thing. All right. Okay. So yes, you can go to my profile and you can gather. Go ahead, purchase away. I appreciate it. Because anything that can be helpful to you guys and keeping things nice and organized, I'm all for it. Okay. We'll get both. All right. Well, thank you. All right. Do I teach Algebra 2? Yes, I do. Actually, Algebra 2 is my jam. I love doing Algebra 2. Okay. So where do I get the workbook? I actually created it. So if anything, I'm just trying to see if I didn't get everybody. All right. Cool. So now, if anything, you guys can always follow me. Do I tutor SAT? I do. Do I love tutoring SAT? No, but I do it. Because anything that I can show, especially, it's all about process elimination. They don't care that if you know it 100%. They just want to know, did you pick the right answer? And a lot of people just don't understand that. Okay. So yeah, a lot of my students are on spring break this week. So if you need assistance with anything this week, this will be the perfect time to grab me. All right. Well, hey, how are you? Haven't seen you forever. What class is this? This is basically a lot of Algebra 1. So I'm just reviewing some probability. We're going through experimental and theoretical probability. So we just did like a whole bunch of theoretical probability. And now we're getting ourselves into a little combination. So I'm not going to be flipping anything. Just going to get things from point A to point B. All right. All right. So looking at the experimental and the theoretical probability. So we're looking at a standard 6-sided dice that's being rolled. Okay. So remember, some people call it a counting cube. Some people call it a die. No matter what, it gives us 6 sides and it goes through numbers 1 through 6. All right, I think today is the 13th, so let me put my today's date on there. All right, so theoretical probability. So this is something that we know. Bruh, let's do this. All right. So I generally don't gamble, but I know some of the things because of the math concepts. All right. So what is the theoretical probability? So if in order for me to get a 1, there's 1 out of 6 sides. So remember, it's always what you're looking for, which is going to be inside the parenthesis, okay, versus the total. So we're looking at 1 out of 6. And I'm going to say 1 out of 6 for all of these. Because in order for me to get a 2, that's going to be a 1 out of 6 chance. In order for me to get a 3, that's 1 out of 6. In order for me to get a 4, that's 1 out of 6. Same with a 5. Same with a 6. Okay? So that's theoretically, because we haven't actually taken a die and rolled it. We know that there's 6 sides, and I know that there's only 1 on one side, there's only 2 on one side, 3 on one side, 4 on one side, 5 on one side, and 6 on one side. Now, a student rolls a die 50 times, records his results, okay, and he put it in this table over here, okay? That is an experimental probability, because the student sat down, got a die, and rolled it 50 times, and then recorded what he or she got from those rolls. All right? So now we want to see what is the experimental probability. So if I may, in order for me to get a 1, let me see if I can fit both of these on here. Probably not. I'll just have to keep going. So in order for me to get a 1, I'll just make this large. They got a frequency of 5, but it's not going to be 5 out of 6. They rolled that dice 50 times. So it's actually going to be 5 out of 50. Okay, so that's going to be the probability of getting a 1. It'll be 5 out of 50. But 5 out of 50 can be reduced. If I reduce it by 5, this will give me 1 out of 10. Okay, good. So for me to get the probability of a 2, here I go to the frequency table. So for me to get a 2, it's going to be 8. So he got 8 out of 50 rolls. And since they're both even, 8 out of 50, that's going to be 4 out of 25. Divide the 8 by 2, get me 4. Divide the 50 by 2, gets a 25. Okay. No problem, Ryan. Have a good night. Let me know if there's anything that I can do to help to make sure you're good with your test, okay? Just go ahead and message me. All right. So for me to get a probability of a 3, go into the frequency table. We got a 10. No problem. So that will be a 10 out of 50. 10 out of 50, they both end in zeros. You can cancel out those zeros to get my 1/5. Okay, good. It's good to see you guys are keeping up. This is awesome. This is great. One of these days, I'm going to figure out what to do with my subscriptions. See a lot of people checking in and giving me the heart, and I still don't know what the hell to do with it. Okay, so now the probability of getting a 4. So here I go with the 4s. It came up 6 times. So 6 out of 50. All right, 6 out of 50. If I reduce it by, or divide by 2, that will give me 3/25. Okay, so 3/25, they don't have anything else to reduce by, so that's my final. Okay, so the probability of getting a 5 will be my 12. So we're looking at 12/50. And 12/50 reduced by 2, divisible by 2, or reduced by 2, I should say, will give me 6/25. Good. Doing good, Pog. Good job. I think you're the reason why I'm doing this, if I'm not mistaken. Because you were like, yeah, I don't get probability. And it seems like you're rocking it out. This is awesome. All right. So now, the probability of getting a 6, so it's a 9. 9 out of the 50 rolls. So since it's 9 out of 50, and there's nothing that 9 and 50, one's odd, one's even, so it won't be able to be reduced. So we're just going to keep it Melody. Hello, dear. All right. So here comes this lovely question. So it asks, if you had to predict long-term results based on the information above, which probabilities would you rely on? The theoretical or the experimental? And explain your answers. Okay, never learned it? Well, you're doing good. You're doing great. So, we did theoretical, we did experimental. Which one of the two would you rely on? If you could take a guess. You can say T for theoretical or E for experimental. Okay, so you would say experimental. Okay. Okay. T for theoretical. Okay. Experimental, Danielle. Say T. Danielle, because you actually tested it. True. Okay. Love the explanation. Long term would be T. Okay. Because that's what we're looking at. Long-term results. Okay. So for long-term, it's going to be theoretical. The reason why, yes, he did do the experiment, but he only did it for 50 times. 50 is a really small sample size in order to really get the actual equality of the effects. So anytime you see people doing, so yay! Okay, anytime you see people doing any kind of probability and they're like, oh, I did 50 rounds, immediately tell that person to do more. Like, you really should be like in 500s and even in the thousands. So that's why some people have like simulators. And I know on, I think I could find it real quick. Okay, so if I go on my graphing calculator, so these are, it does other things other than just calculate, okay? So if I go to apps, it will give me a whole series of things that this calculator does. It's almost like your phone. Everyone thinks that, oh, it's just a phone. No, it does stuff. It can change the language, okay? You can deal with inequalities a little bit more. You didn't know that you had all this, right? Now, where it has prob sim, that's probability simulation. So if you ever want to, I'm going to push any key. If you want to toss coins at a large amount, if you want to roll dice, if you want to pick marbles, if you want to spin a spinner, draw cards, or even do a random number generator. Now, as a teacher, I use this a lot for me to figure out who should go first, second, third, because in the classroom, no one wants to volunteer. So if you ever want to, yes. So if you ever want to do something at a high rate, instead of you sitting there flipping coins all day looking like a crazy person, you can actually have the calculator do the simulation for you. Okay? I used in high school. Yep. I know. TIA 3 Plus. I've had this. Oh, God. When I first started teaching, and this is one of the, I don't want to say the original ones, but this one I went to a professional development and they gave it to us to try out. I think I was working in Baltimore County at the time, and I was like, oh, cool, a new calculator. And yeah, no one really had the silver edition for the longest time. So maybe this might be in the archives or somewhere, but never know. All right. So I want to quit, did that. Okay, so if you ever want to do that, you can do that, right? I think it was it 2004? Probably was. My God, time just flies. So yes, in a situation like that, since this happened, they only did it 50 times, and we're looking for a long-term results, we definitely want to go with the theoretical in this situation. Now, here's my other thing. So if a student were to roll a dice 200 times, okay, 200. So we know that we have to figure out our 1/4. Okay, so if a student were to roll it, and we're talking not the experimental, we're talking the theoretical, because remember, we want to use that as a reliable source. So if a student were to roll a die 200 times, how many times would you predict he or she will roll? So if we're saying that the probability of getting a 4 is 1 out of 6, and they rolled it 200 times, roughly, let's try to round it to like a nice even number. Okay, because we can't have 2.5 times. You can't roll half of a time. Okay, so you want to round it to a nice even number. How many times would that person or that student roll? What do you think? If the probability is getting 1 out of 6, getting a 4, and they rolled 200 times, roughly how many? So I'm going to use my approximate. Oh, pretty brown eyes. Hello. Oops. I gotta stop hitting my phone and calling up things. What do you think? Okay, so you got 33.3%. So if we look at turns or rolls, it'll be approximately 33 rolls. Okay, so it'll be approximately 33 rolls. All right. So, not a 4. Okay. What's the probability of not getting a 4? So remember, if there's 6 sides to it, not getting a 4 is going to be what out of 6? Okay. Thanks, Gray. Gray's saying 5 out of 6. Do we agree? I agree. So we got 5 out of 6. Good. We got our 5. So if we're rolling this 200 times, roughly how many times? I'm going to put it down here. Good. So how many times? Okay. 166. What's after that other 6, Gray? Because wasn't there like a bunch of 6s repeating? Because it wasn't like 1.66.6666666 and it just rounds to the 7. So you can round up the fraction rule. So you round down. But if I round down, would it short me? Just curious. Hey, lovely Sam. What do you think? Would it short me or should I still? Okay. So if you're solving for probabilities, that's all add to 200 rules, then yes, it would be. Okay. Okay. Keep the entire number. You might need it later. Okay. So what should we say? Like 166 or 167? Let's just make a decision now. What would you think? I'm pretty easy going, guys. It's really nice. Okay. So about like 167. Okay. And then, of course, here we go. We got that approximation. Okay. So since we're kind of talking a little bit about that approximation, we can keep it to like the 167. Because it's not exactly 167. But if we do 166, approximately 166, it's kind of giving us a little short. So let's just say approximately 167. Okay. All right. And the next one. So getting a 1 or a 6. Okay. So for us getting a 1 or a 6. So that's going to be what out of 6? How many possibilities out of 6? So getting a 1 or a 6. How many possibilities? And this is a number or a die. We're all stuck. You're like, the music is soothing me. So for us to get a 1 or a 6, that's going to be 2 out of 6. Or we can reduce it to 1/3. And then since it was rolled 200 times, it's going to be roughly about what? Yes, so 200 divided by 3. That's correct, H. What would that be, roughly? It's like 60 something. So wolf song. Okay, roughly about 67. Okay, we agree with it. Okay, like 66.6. So roughly about 67 if we round it approximately. Okay, good. I know. Thank you. We don't need to conjure him up. That's the last thing we need. All right. So, all right. I think that's basically, we get the gist of this. I don't want to beat a dead horse, right? But I definitely want to kind of slide over to, let's see, my other side. Let's see if we can just do one of these, and then we will call it a night. All right. So let's look at this one at the top, this number 9. So we got marbles again. They always do marbles, spinners, coins, right? So we got marbles are drawn one at a time from a bag from an unknown number of marbles and replaced each time. So Robert picks a marble out of the bag, puts the marble back in. He did this 25 times and recorded his results in the table on the right. Whereas Kylie picked a marble out of the bag and put the marble back in. She did this 2,500 times and recorded her results in the table on the right. Okay. So whose result would you trust more? Would you trust Robert's or would you trust Kylie's? Go ahead and put it in the chat. Who would you trust more? Robert or Kylie's? Okay, Pog says Kylie. Hey, Miss Lucky. Okay, Miss Lucky says Kylie. Key says Kylie. All right. And why are we saying Kylie? Yeah, Pog. Are you in my brain, Pog? He's like, Jinx. Yes, okay? Because she did a heck of a lot of trials, all right? We're going from 25 to 2,500, okay? Because she definitely had more trials. Now, if we're going to rely on Kylie's information, all right, so I'm just going to write Kylie right here. And I'm just going to write more trials. Now, what is the best estimate of the probability of getting a white? And let's use Kylie's. So what will be, let me see if I can zoom in. What will be the probability of getting a white marble? All right. Definitely have more times. Good. Oh, the Flash, thank you for sharing the live. Appreciate it. Okay, we already know how many trials there were. So we got that. Okay. Probability of getting a white. Okay. All right, so Miss Lucky's saying 868. Okay, we got it right here with 868. Now, I know this is going to be crazy. They're both even, It could be reduced, but here's my thing. Give it to me as a decimal. Give this to me as a decimal so we won't kill each other with the torture. 2.8. Are you doing it the other way around? Hold on. Yeah, make sure you type in the numerator first, then the denominator. Okay, so the flash is saying 0.34. Okay, so roughly 0.3472, I would take it. So roughly like 34.72%. Okay. I would take 0.3, but if I was going to go to 2 decimal places, it would be 3.5. If we could. All right. Well, I think we kind of got it now. So the experimental probability is when you're actually doing the trials. There we go. Good. So the experimental probability, we're actually doing the rolling, we're actually doing the flipping, and we're recording our results. And we all know that the more results that you do, the better it's going to be. Right now, all right, awesome. Turn to decimal. It wasn't wrong. So how I was taught to turn to a decimal was wrong. Well, I don't know. What did you do? Yeah. So like if you want to make sure you, I think this was you. Yeah, make sure you like do your numerator then your denominator. This divided by this. Okay, good. All right. So theoretical is you know that there's 6 sides to a die, and you're like, okay, what's the probability of getting a 2? It's going to be 1 out of 6. But I didn't necessarily roll a die to figure that out. Okay, I just know theoretically that there are 6 sides to the die, and I know one of the sides is a 2. All right, so I think that is it for me. I know today was my second time coming live, which is good. I appreciate you guys coming out because I know my numbers are going to get lower because a lot of people are on spring break and learning math is the last thing that they want to do. But if you know of someone that had a very interesting teacher that gave them a packet to do over spring break, which is hilarious, but they need some assistance with that, please pass my information over to them. Okay, so I'm coming back. I'm starting my 3rd notebook. But again, if you guys can help me out, hey, go ahead, like and follow me here. You divide your denominator into your numerator plus. Yeah, it's the other way around. Okay, it's the other way around. So if you can subscribe to my YouTube channel. What I generally do is I like to put my lives that I get here on TikTok and I upload it there. So this one's going to probably be up in the next couple of days. Then as well as I will be live again tomorrow night, but it's going to be tomorrow night at 8:30 because I have tutoring. And I might come a little bit early, but it's going to either between 8 or 8:30. And then if you have an opportunity, if you can do a Google review for me under ACG Math Tutoring, this is what I do. I tutor all day. I used to be a classroom teacher and a professional basketball player. Yeah, I used to do that. I was a baller. And if anything, I've been tutoring for like, this is my 5th year. I can't believe it's April already. And actually, it's the middle of April, which is insane. But I love doing what I do. I come on here to basically help a lot of people to get them ready for their GED, Accuplacer, ASVAT, or maybe just help them with their current class. So like Noah, he's learning this, and even the Flash, he's learning this right now. So anything that can be helpful to kind of reinforce what you're doing, hey, I'm here for it. All right, so I'm just going to finish up a little bit more with probability. That's what I'm trying to shoot for the rest of this week. And I'll actually try to do a little bit of mean, median, and mode, like get the measures of central tendencies, as well as the measure of variance, and then try to look at the different ways that information is displayed. All right. So again, if you love my math notebooks, again, it's like 100 pages. You have some that is blank like this, and then the other side is the gridded side where it'll have like all the resources. Go ahead and just click the link in my bio. And I think next school year, I'm going to have one just for geometry. And then I have some other stuff that I want to add into it. And yes, we're going to be doing complex events. We're going to be doing fundamental counting principle, and then mean, median, and mode. All right. So if anything, if you ever get stuck and you just need someone to kind of like, hey, Audrey, can you take a look at this? Just let me know. Just shoot me a message, and we'll take it from there. All right. I'm glad you guys came out. Thank you so much for the taps and the gifts and functions and transformations. I actually did. So go to my YouTube channel. I have some videos on functions and transformations. I'm not sure if I think I did for vertex form. So take a look in there as well. Okay, and then you could just speed on through and just grab what you need to grab. Okay, all right. I definitely know I did that. What else? What else can I do? All right, no problem. And if you get stuck on something, you just want me to take a look at it, just let me know. And it's like, as long as I get a heads up, this is the week to do that. Because next week is going to be a full steam ahead. But I am helping people with their GEDs, some that are taking college courses, and some people that are taking on their ASVAT. And what else are we working on? Yeah, I have a couple people taking their ASVAT at the end of this month. So if you need assistance, just let me know. All right. Thank you so much. Pal, thank you. I know you're always tapping away. If we can get it to like 5K, that will be amazing. I know there's 9 of us here, but if we can get it to 5K, I will greatly appreciate that. Just a quick little mad tap, like as maniacs, and then we can go on our way. Perfect. Yay! That will be fabulous enough. I don't ask for too much because, I don't know, that's just me. All right, so if anything, I'll probably see you guys tomorrow night. Again, it could be between 8 and 8:30. It actually might be 8 o'clock because it actually might be a little bit earlier than that. But we'll see how it goes because I don't want to do a 10 o'clock, not tomorrow night. Maybe Tuesday night, definitely Wednesday night. I'm going to be late on Wednesday night. All right. So I will see you. Keep being awesome. Keep working hard. Trust me, it's going to pay off. It really is going to pay off. And before you know it, boom, the school year is going to be over. Before you know it, it's going to be time for you to take your test. And I want you to go in there and take the test and treat it like you are the boss. All right? Because you can definitely do this. You're talking to a person that hated math. Like I used to suck at math. Fractions, was terrible at it. Word problems, don't even talk to me about it. Okay, so I get it because I went through it. So that's why I like to come in here, have the nice, quiet, soothing, let's focus type music. And this is a safe space for you to ask your questions. It's a safe space for you to just do all the things that you need to do. Okay? All right, guys. Thank you so much. And I will see you tomorrow night. All right. Take care. Bye.